Hi everyone. Today we are going to learn finding values of trigonometric functions based on the unit circle. Functions on a unit circle. So unit circle means a circle whose radius is 1. So this length is 1, this length is 1, and here x value, y value, when a point is provided on a unit circle, x value is equal to cosine theta, y value is equal to sine theta. So you might say, why is that? Well, let's say this is a terminal you are dealing with. Let's say this is the angle of theta, and let's say this is a coordinate x, y. You can draw a right triangle like this. This length, you went to the left, that's x value. You went up, that's y value. It's a unit circle, meaning radius is 1. This length is 1. This is also radius, so that should be 1. So if you're trying to find the sine value, cosine value of this angle, you have to label it. So if you label it opposite side, this is opposite, because this is a reference angle you're dealing with. Opposite, hypotenuse here, adjacent here. So if you calculate sine value, so ka toa, sine value will be O over H. Sine theta will be O over H, y over 1. So sine theta is O over H, y over 1. Well, over 1 doesn't do much, meaning sine theta is equal to just y. If you calculate cosine theta will be A over H, which is x over 1. X over 1, again, over 1 as a fraction doesn't do much. Cosine theta becomes just x. So that's the logic behind. Why is x value cosine theta? Why is y value sine theta on a unit circle? Then that's the story. So what do you need to know? Here, if you see the word unit circle and the point is on the unit circle, then x value is cosine theta, y value is sine theta. That's all you need to know. Okay, first question. The terminal side of the angle theta in standard position intersects the unit circle at P, unit circle, right here. That's the key word, unit circle. And that's a cosine theta, that's a sine theta. So that's asking, the problem is asking, find the cosine theta and sine theta. Well, that is a cosine theta, that is a sine theta, and then that's the answer. You're done. You should try this. I mean, it's the same question. Just for the side note, if they ask you tangent theta, this problem did not. But what if they ask you tangent theta? The tangent theta is equal to sine theta divided by cosine theta. So sine theta divided by cosine theta. So that will be equal to what? Sine theta, which is 3/4 over square root of 7/4. You need to simplify this. So this fraction over this fraction means this divided by this. So that's exactly same as 3/4 divided by square root of 7/4. Okay, divide by fraction is the same as a multiply by reciprocal. Multiply by reciprocal. Flip it. Then 4 and 4 cancels out. It becomes 3 over square root of 7. You cannot leave square root on denominator. So rationalize denominator by multiplying by square root of 7 over square root of 7. Denominator becomes 7. Numerator becomes 3 square root of 7. That will be answer for tangent theta if we ask you to find tangent theta. This problem did not. Just side note. Okay, next question. Find an exact value of cosine 690 degree. So if this was the question, find the exact value of cosine 690 degree. First thing you would do, 690 degree is more than 360 degree. So first thing I'm gonna do is I'm gonna find the coterminal angle, which is between 0 degree and 360 degree. How? You can subtract 360, add 360 as many times as you want. You can use a calculator if you have calculator available. So if you subtract 360, it becomes 330 degree. What does that mean? Cosine 690 degree is exactly same value as cosine 330 degree. And I'd rather find this value than this. So cosine 330 degree, I'm going to graph it. Where's the cosine 330 degree? 0 degree, 90 degree, 180 degree, 270 degree, 360 degree. 330 degrees should be somewhere all the way up to here, somewhere between here. It should be somewhere over here, 330 degrees, all the way around 330 degrees. Okay, when you draw the triangle, you have to draw a triangle against the x-axis. Do not draw a triangle like that. You want to draw a triangle against the x-axis. You need to find this angle. We call that as a reference angle. So difference between these two angles becomes 30 degree, 30 degree. Reference angle is always positive. Okay, right here, you should notice, this is a special triangle, 30, 60, 90 triangle. So if you look at my previous video, we dealt with this special triangle already. So what are we looking for? Cosine 330 degrees, 30, 60. So you should memorize this special triangle, 1 to 2 to square root 3. Then you can apply 1 here, 2 here, square root 3 here. Length of ratio, you're supposed to memorize it. Okay, when you go down, make sure you put minus. Then you go to the right, that is a positive. If you go left, if you go down, you put minus. We are dealing with a cosine, so that's a reference angle. Label the length of sides. So that will be opposite length of this angle. Longest one is always a hypotenuse. Leftover is adjacent. You're looking for cosine. So, ka, toa. So cosine is what? Cosine is a over h, a over h, a over h. So that will be a over h square root of 3 over 2 will be your final answer, square root 3 over 2. Okay, you should try this by yourself. Pause it, try it. This will be exactly the same style, except we gave you angle in radian. So if you are familiar with the radian, you can just draw it, locate it, and deal with everything as it is, as a radian, do it. If you're not familiar with the radian, best way might be convert that to degree. How? Convert that to degree by multiplying by 180 degree over pi. So pi on numerator denominator cancels out. So 4 divided by 4 divided by 4, 45. Multiply by 3 times 45, it should be 1. 135. You can use calculator. minus 135. So I just converted this sine minus 35 using a degree. So that's the same as sine minus 135 degree. If you don't like minus 135 degree, you can add 360. Well, I kind of like it. So I'm going to just draw it as it is. 0 degree minus 135. You go clockwise. Minus. It's minus 90 degree here, minus 180 degree here. So minus 145, 135 should be somewhere over here. That's minus 135 degree. Again, how are you going to draw a triangle against the x-axis? So draw a triangle like that. You need to find reference angle, which is always against the x-axis. This is reference angle, not this. How do you find this angle? You get the difference between these two. And reference angle should be always positive. So this minus this, or this minus this. You can use a calculator, just change it to positive. So you will get 45 degree. If you do minus 180 minus 135, you will get minus 45 degree. Reference angle is always positive. So you can do this minus this, you get positive. Okay, then you should notice, this is a special triangle, 45, 45, 90. Again, you should know that 45, 45, 90 is 1 to 1 to square root 2 ratio. You should memorize that. Then 1 to 1 to square root 2. Be very careful. This is the part lots of students make a mistake. When you go left on x-axis, you have to put minus. When you go down on y-axis, you gotta put minus. Hypotenuse is always positive. This longest side is always positive wherever the triangle is located. We are interested in sine value. Let's label the length of side. Opposite of this angle is opposite here. Longest one is hypotenuse. Leftover will be adjacent. We are looking for sine 135. Sine again. So ka toa sine is equal to O over H. O over H. So sine 1 minus 135 degree will be O over H. O over H. Minus 1 over square root of 2. You are supposed to rationalize the denominator. You cannot leave root on denominator. So multiply by square root of 2 over square root of 2. Denominator becomes 2 minus square root of 2. That will be your final answer. Okay, you should try this by yourself. And you are ready to do Alex homework number 8. Okay, guys, that's all for today.